For this polar integral, we're actually going to be integrating a polar graph. So we're going to find the area of one petal of the rose curve, a petal being kind of the petal of a flower. And that rose curve equation is r of theta equals cosine of 3 theta. I've also written down this below because we're going to need it to actually do the integral. So here we go. To get one petal, we could choose any petal we want. So we might as well choose the easiest one. So if we start at this dot there, that's actually this point here. Right, so we're at theta is 0, and then that was r of theta is 1. And then if we actually continue along the upper edge here till we get to there, that's actually this bit right here. All right, and so if we go from 0 to whatever that is, then that's going to give us 1/2 of a petal, and we could double it if we want to. So at this point, normally cosine of theta, it'll be 0, this first 0 is at pi over 2. Since this is cosine of 3 theta, that point is actually pi over 6. And so what we can do is we can set up the integral. So integral, integral. And essentially the integral we're doing is 1 for area, and then that's times r d theta. Then we're integrating r from 0 to cosine of 3 theta, no, that's right, 3 theta. And then theta, we're going to have 0 to pi over 6. And then since that's only half of a petal, we're going to double the integral to get the entire petal. So, and then one of the things to watch out for is I also want to do only half the petal here, because after we go past pi over 6, r of theta actually becomes negative, and that does some weird things to the integral and ends up being, I think, negative area. You can kind of see that from the bounds. So if you go from 0 to cosine of 3 theta, if you're between theta 0 and pi over 6, you're going from 0 to a positive number. Once you get to pi over 6 for theta, the integral goes from 0 to 0. So that's not that bad. But if you keep going, then cosine of 3 theta will be negative. So for instance, if I had pi over 4, whatever, it's down here, 0 to cosine of 3 times pi over 4, that would actually be 0 to a negative number. And right, when you have integral bounds, it's supposed to be from, the lower bound is less than the upper bound. All right, so another thing to watch out for, this would have come out weird if we had just blindly gone ahead and used r values that were negative. All right, so you have to be careful, messes up the integral bounds, they're in the wrong order, and some other weird stuff, so just try and avoid it. But here we go. So now we have the integral bounds. We have an idea to do it. We double check that r is positive the whole time to make things easier, less confusing. We're integrating area, so we have our 1 for the area, and then times r d theta. Then we have integral bounds 0 to cosine 3 theta, 0 to pi over 6. So let's just get started. So we have 2 times integral 0 to pi over 6. And if we evaluate, this is a r, so if we integrate r with respect to r, we end up with 1/2 r squared, and that's evaluated from 0 to cosine of 3 theta, and then we have our d theta. All right, well, that's not too bad, so that's equal to, we still have our, well, actually I can cancel some stuff, so I have the 2 and the 1/2 cancel, so I just have integral from 0 to pi over 6, and then r squared, so plug in the 0, you get 0, so really we only have to worry about cosine squared of 3 theta d theta. Right, so it's the last integral we have to worry about. All right, we don't know how to integrate cosine squared, so that's why I had this hint pre-written at the beginning. So if you have cosine squared of something, it equals 1/2 1 plus cosine of 2 times that something. So we can rewrite this as the integral from 0 to pi over 6. So that's going to be 1/2, and then I've got 1 plus cosine of 2 times the thing inside. So it ends up being 6 theta. Right, and my d theta. Now we can integrate that. So let's see, that's a 1/2. So I've got a 1/2 theta. All right. And then I had a 1/2 times cosine 6 theta. All right, I think that'd be plus 1/12 sine of 6 theta, and that's evaluated from 0 to pi over 6. All right, so let's go ahead and do that. Not quite enough room there. I have plenty of room down here, so 1/2 of theta, 0 to pi over 6. Okay, well that ends up being 1/2 times pi over 6. I'm not going to worry about the 0 because 1/2 times 0 is 0. Okay, also my plus 1/12. Okay, so I have sine of pi. Right, if I plug in pi over 6 into theta, I get 6 times pi over 6, I get pi. Then I would also have a minus 1/12 sine of 0. But these are actually, they're both 0. Right? So the whole thing ends up being just pi over 12. All right, so that's the area of one petal of this rose curve with just 3 petals on it.